How do polar vortex shifts create cold snaps? Imagine a giant swirling air mass high above the North Pole, holding back the coldest air. That's the polar vortex, a huge area of low pressure and frigid air that spins around the Arctic. Normally, it keeps the cold air locked near the poles, so most of us don't feel its full chill. But sometimes, this vortex doesn't stay in one place. It can shift, weaken, or even become distorted, and that's when things get interesting. When the vortex moves or wobbles, it can send icy air streaming southward into places far from the Arctic, causing sudden cold snaps. This process starts with changes in the shape and strength of the vortex itself. Instead of being a tight, circular mass of cold air over the Arctic, it can stretch out or become displaced. These changes often happen because of large atmospheric waves, big disturbances in the jet stream that move upward from lower levels of the atmosphere. These waves can weaken the vortex and make it wobble or split into smaller lobes. When that happens, the jet stream, which normally acts like a barrier between cold polar air and warmer mid-latitude air, becomes more wavy and dips southward. These dips, called troughs, allow the cold Arctic air to spill into regions that are usually warmer, leading to rapid temperature drops known as cold snaps. There are two main ways the polar vortex shifts that influence where the cold air goes. One shift toward western Canada pushes cold air into the northwestern United States and parts of western Canada. The other shift toward the North Atlantic sends cold air into central and eastern North America. These shifts can last from a few days to several weeks, bringing extended periods of freezing temperatures, snowstorms, and icy conditions. Sometimes, the vortex undergoes a sudden warming event in the upper atmosphere called a sudden stratospheric warming. This rapid warming can weaken and disrupt the vortex even more, making cold outbreaks in the mid-latitudes even more intense. From the polar region's perspective, these shifts are disturbances in the normally stable, cold air mass that stays near the poles. While the vortex is a constant feature of polar atmosphere, its variability has a big impact on weather from the Arctic. When the vortex shifts, it can cause extreme winter weather in populated areas, making it important for weather forecasts and preparations. Understanding these shifts helps us better predict when and where cold snaps will hit, so we can stay safe and plan ahead for the cold weather surprises.